طيب بسم الله الرحمن الرحيم. So we started in this chapter talking about user authentication. We talked about the concept of user authentication, and then we gave some idea about the key distribution. We talked about the NEST specification for user authentication and key distribution. And we started giving some introduction about Kerberos, which is a user authentication and key distribution protocol at the application layer. We'll talk about similar key distribution protocols from other layers as well in a later stage. So for Kerberos, it was used for key distribution and user authentication service, which is developed by MIT, as we said. It's based on centralized authentication, so there has to be a KDC or key distribution center, which in that case it's combined between the authentication server and the ticket granting server, as we will see in a minute, and it relies exclusively on symmetric distribution or symmetric keys. So it's not based on public cryptography. So the important terminology about Kerberos is that it uses the key distribution center, which is combined. It's a combination of the authentication server for user authentication, and then the granting server, which distributes the session keys, which is service oriented or service specific. Okay, so together, these two together, they form the concept, or they form the entity of key distribution center. Okay. Of course, version 4 uses this, except that this has been updated in version 5, and they updated the protocol to use different cryptographic technique like S. So, in terms of requirements, if a certain user logs on to a workstation in the morning and wishes to check his or her email at server, okay, server V, okay, C authenticates through the authentication server to get a ticket, okay? So the concept of ticket here, the ticket has the purpose of granting access to the node or to the user C, okay, granting access to a specific node in the distributed system, okay? And this ticket has a certain lifetime or a certain duration through which, yes?
This is the same concept of token.
Similar to the token, right? So it has, but of course it's unforgeable, which means that even the user cannot copy that ticket. The user, C, cannot copy that ticket or cannot see what's inside. But the user has to include the ticket, okay, with all types of communications to this particular node, as we will see. Okay? Type. In order to get that ticket, C must use a password, but the password here cannot be sent to the authentication server as plain text, as we said. So we need some solution for that. So if C wishes to check the email is a specific service, okay? So then C requires to now re-enter the password again, right? So the fact that you have authenticated yourself to the authentication server, okay, that does not include a specific service, okay, like email or Blackboard or something like that. So we have to send. The question is, do we have to send the password again and re-authenticate the user again using user ID and password? Okay. Of course, the answer is no. We don't have to do that, because then we can use the ticket, okay, that we have achieved from the first step of user authentication. Okay. So first, we need to perform user authentication, through which we get a ticket, and then from this ticket we can send it to another server, okay, to gain access to a particular service. Okay. So, of course, so we need to do that on 2 stages because, as we said, there are 2 different parts of the key distribution center, which includes what? The authentication server and the ticket granting server. Authentication server gives you access to the entire distributed system. Or it's like when you enter the cinema, first you have to get a ticket to enter the cinema, but that doesn't give you access to a specific movie, right? So a movie is like a service. It's like Google, so I can authenticate myself to all Google services or to the Google system, right? But if I want to check my email, that's a particular service inside Google, in which case, if I have the basic user authentication, then I've got a ticket that I can use, okay, and then authenticate myself to the Gmail server, right? So which is a service-specific authentication. Okay, so in other words, the authentication is done on 2 stages. One is like basic authentication, and the other one is service-specific or service-oriented authentication, right?
Call this the second stage is like
Second stage,
authorization?
right?
Authorization?
No, well,
Permission?
not really. No. We'll talk about authorization in a later stage. Authorization is different. Okay. So the ticket granting service is needed so the user can get a ticket for each service, okay? So because you have plenty of services. You have Blackboard, you have Gmail, you have email, you have whatever. Then the ticket granting server is now a service-specific authentication, performs the service-specific authentication. So we'll see the 2 stages now. So, so the first stage here, so stage 1, is that the user needs to authenticate himself, okay? Send a request to the key distribution center, the specific part of the authentication server, right? So we'll see how this is done now. So one requirement here is that we can send the user ID, no problem, but we cannot send the password as plain text, right? We cannot send the password as plain text. And of course, we cannot encrypt it because we don't yet have a key, right? We need to perform the user authentication in order to have a specific key, right? صح كده? So we don't yet have a key, right? So that's a discrepancy now, right? So we'll see how this is done. If we are able to authenticate ourselves to the server, then the server can send us a ticket which grants us access, okay, to the basic system, okay? It's not a service-specific access, right? So this ticket would have a lifetime, a certain duration, lifetime, after which it expires and then you have to authenticate yourself again. The other thing is that it sends us the key back, the key that we can use from now on to encrypt all the upcoming messages, okay? Usually this session key is a semi-permanent key or a long-term key because, again, this key is to be used later on in all services, okay? So for each service, I need to establish a session key or a temporary key to access that particular service. In order to distribute this temporary key, I use the original key, which is the master key. They call it like a master key or a semi-permanent key or a long-term key, okay? واضح كده? So this ticket, okay, again, it grants us basic access to the system, but it's not service specific. Then I need to use that particular ticket in step number 2. So in step number 2, I use the ticket, okay, which I have been granted, to send a request to the ticket granting server. Okay, this ticket granting server بقى, in this request, I need to highlight or I need to identify the service that I want to access, whether it's an email or Blackboard or whatever, okay? So with that, I send a ticket which is my granted access, which is my granted access to the basic system, okay, which has a certain lifetime. Okay, those two together will allow me to get access to the ticket granting server, and as a result, the ticket granting server can send me a response. This response would include what? Would include two things: a service-specific ticket, okay, and a temporary key which I can use to communicate with the service server, whether it's an email server or whatever. واضح كده؟ So these are the two stages of authentication. So now we need to answer some questions back. How can we perform user authentication without sending the password as plain text? Okay. What is the content of each of these messages? Okay. And what is the meaning of each field in these messages? So that's what we need to follow. I have to also highlight here that the user authentication, by the way, has to be attached to a particular workstation. So you are authenticating yourself, which is your user ID, but you are getting the ticket, okay, to access the system from a particular workstation. And as we said, this will avoid the fact that another user here will not use another workstation to pretend that he is you, and he can perform some attack, man-in-the-middle attack. واضح كده؟ طيب. هنا بقى التركيز بقى. We need to focus here because there are يعني lots of details in this handshaking protocol, and each of these fields, they mean something. Okay. So we get to the depth of this. So in the first request, the user needs to authenticate himself. We need to perform the initial user authentication. And I like to differ a little bit from the book here, just to make like a standard way of forming these messages. So this is ID TGS. I will start with this, unlike here. ID TGS is like, this is the target node that I want to access. So I'm just sending this request initially to get access to this server, okay? Which initially, of course, this server is the ticket granting server. It's not a service specific server, okay? So I need to access this, and while sending this, I need to send my authenticator بقى اللي هو my ID. My ID is like username, okay? And this username is plain text, no problem. I can send it as plain text, no problem. And then I need to send the timestamp. Those two, they are called authenticator of the user C or the node C, okay? Why do we need to send the timestamp? Huh?
For data integrity, it's
huh?
Session
Session what?
Session not a specific time, so it starts
to
from
avoid
أيوة, to avoid replay attack. Yes, you're right. Okay, so we said that to avoid replay attack, we need to make sure that this message is fresh. Fresh meaning that we need to include either a sequence number or a timestamp. Okay, so the timestamp here is to avoid replay attack. Well, type. Okay, so we did not send the password. Okay, but this authentication, it doesn't seem to be complete now. What we will get back is something that looks interesting. I will get an encrypted message. I will get an encrypted message. So this whole message is encrypted. And as you can see, all the replies are actually encrypted. All the replies from the servers are actually encrypted with a specific key. Type يعني هتقولي what key? Which key? Okay. So this message is encrypted with a key which is specific to that user. This key has been generated based on hashing the password of the user. Okay? Of course, in the registration part of the system, the server has your password, right? The server has or generated automatically some kind of password for you or something like this, right?
You mean the AS, right?
Yes,
AS
the authentication server now has your password in one way, shape, or form. And in, more often than not, it does not have this password stored in the database even as plain text. It's hashed. And we'll talk about this in a later chapter, how the password is actually stored on the system. Of course, it's not stored as plain text. Okay, stored in the database in a specific form, which is hashed. Okay? So what the authentication server does is that it actually generates a key based on this hashed password. And of course, the user can do the same, right? Because the user knows the password. So both of us, we know the password, but we cannot communicate it. So the ideal solution now is that the server or authentication server will create a puzzle for me. Okay? This puzzle, okay, is kind of encrypted with my password in a hashing format. If I can solve this puzzle by having the password, I can decrypt that message, in which case I can get all what I want. Okay? If you cannot decrypt this message, then you cannot get anything. Okay? So, in this message, so this message is encrypted. Okay? The message contains what? Contains the temporary key or the session key, which is actually, it's not a temporary key. This is actually a long-term key or the semi-permanent key. Okay? Which is used to create some kind of communication with the ticket granting server for all upcoming services. Okay? This is service agnostic. And it's symmetric key between the user and the ticket granting server. Okay? So that's very important now. So we use the user authentication to distribute the master key or the semi-permanent key. Okay? And together with, of course, this key, okay, has a specific lifetime. And also we communicate the ticket, which gives me access to the ticket granting server. So I now have a ticket, and the ticket gives me, granting me access to the ticket granting server, right? Which has a specific time duration. And in order to communicate with the ticket granting server, I need to have a symmetric key. Okay, so those two are very important two pieces of information. Of course, the key, both the key and the ticket, they have a certain lifetime, which is a duration of time, right? And of course, we send the timestamp. We send the timestamp, of course, again, on one hand, to avoid replay attack. On the other hand, also, together with the lifetime, can allow me to know when the key will expire, right? So if at any point of time I see that the current time is greater than the timestamp 2 plus the lifetime, this means that the ticket is expired. So, okay, I will not grant this user any access to the system anymore. So the user has to go through the user authentication again, which has to go through the authentication server again from the beginning. واضح كده? Okay, so this is the basic concept. We did not answer the question, why do we need to send here the ID of the ticket granting server in the reply back? Okay, so keep that question in the pool. Okay, so we'll answer that question. Okay, so each of these fields, we know what they are, except for the ID TGS. So here we need two pieces of information: the symmetric key that we need to use in order to communicate with the ticket granting server, and the ticket that we can use to access that server. So once we have this, and we can encrypt it, assuming that we can know the KC, which is based on the password, so we can decrypt this message. We got everything inside it. So now we can send another request to the ticket granting server, now to to access a specific service. Okay? So again, the same thing goes. So here we send the ID or the ID of the target server that we want to access. That's why I started with ID TGS, just to be consistent. So you always have the target server at the beginning, and then you send two things: your authenticator, and if you have a ticket, you can send it. This is basically the format of the request. And the reply is always encrypted with a key that you should have. So this is in a nutshell how the protocol works, right? So request always includes if relevant the target server that we want to have access to, and my authenticator, and the ticket. Okay? So here, my authenticator, so this is the target server that we want to access next, which is a service-specific one. And I'm sending my ticket, and I'm sending my authenticator. So we'll see the content of the authenticator, which is slightly different, because remember, unlike the first stage, okay, in the first stage we did not have a key yet, so we had to send the user ID. Here we do have a key, we do have a symmetric key, right? So the authenticator is going to be based on the symmetric key that we have with the ticket granting server. So we'll see the content of that. And the ticket to the ticket granting server, remember, it's given back to me by the authentication server. It's unforgeable in the sense that even the user cannot really see what's inside. Otherwise, if you have if you enter to the cinema and you get a ticket, if you can actually regenerate that ticket, what's the point of the ticket, right? So you can just regenerate it and gain access to all the movies that you want to watch, which defeats the purpose of that ticket, right? So the idea here is that you can use that ticket without being able to know what's inside. This is very important, okay? So you have the symmetric key, but you cannot have the content of the ticket. So I will send the ticket, and the authenticator together will give me access to the ticket granting server, in which case I need, remember here, I need the session key, which is the temporary key that I will use to communicate with the service the service server, which is server V, okay? So, and of course, I need also a ticket to that server. So we see that here the message on the reply back, it has the symmetric key, which I can use now to communicate with the service server, right? And the ticket that I can use, and also, of course, a timestamp, and we'll see where the lifetime is. The lifetime is inside the ticket as well. So we'll see, and I will see where the lifetime is. Okay, so now we have a symmetric key, and we have and remember also here we have IDV, which is also part of the message. It's similar to here. We have ID TGS, which is part of the message. So you see that we are actually, in the reply, we're echoing back the target server that you have sent in the request. And there is a reason for this. So now, in the third stage back here, now we have the ticket and the symmetric key to allow us to gain access to a particular service server. From now on, you see here, we don't have a target server anymore, because خلاص احنا we have reached the target server that we want to access. Okay? So we just send the ticket and the authenticator to gain access to the server, and the server will send us back a reply which echoes back the timestamp. We'll see here in the authenticator and the ticket there is timestamp 5, and here, unlike the rest of the messages or the previous requests, here it's very weird. Here it has timestamp 5 plus 1. Okay, and again here we don't have a target server that we echo back because we don't have a target server here. واضحة دي? So in the first stage, we have a target server. So the ticket granting server, so the authentication server will send back the target server in the reply. Here, we have a target server, IDV. The server or the ticket granting server will echo back that IDV. Here, but we don't have a target server. That's the main difference. Because this is the service-specific server that we want to have access to. We don't need to access this server to gain access to another target server, right? So in the reply, we don't see any target server, but we see a very strange thing, timestamp 5+1. ماشي كده؟ So we need to answer some questions here. But first, we need to know the content of each of these tickets and authenticators. ماشي? We need to know about the content of this. So again here, I like to format it as ID, TGS, and then IDC, and then timestamp 1. Okay, and those two, we said that we call it a authenticator C. So in the reply back, we will get the reply which is encrypted with KC, and in the reply we have the symmetric key, and we have the ticket which is gives us or grants us access to the ticket granting server, and of course the lifetime. And here in the reply we echo back the ID TGS. ماشي? So why the server needs to send back the ID TGS? There are multiple reasons for this. Because remember, this is the user authentication, right? So whenever you authenticate yourself to a server, the server actually needs to authenticate itself back to you. So just the fact that you are communicating with the server doesn't mean that you trust it 100%. So the server also has to authenticate itself back to you. Okay? So that's why the server needs to echo back this ID to give the confirmation to the user that indeed I know exactly your request and this is coming from me. So this and this together, okay, will confirm that this reply is coming from the authentication server and nobody else. Okay? So the server, so whenever you communicate to a server, the server needs to do what we call, it's called a mutual authentication. It's called mutual authentication. So IDTGS is done first for mutual authentication. Second, it's actually some kind of a confirmation and acknowledgement, right? So you are requesting grant to that server. Okay, so here is the server that you have access, that you have grant to access, right? So it acts as a confirmation as well, or as an acknowledgement. Okay, so you are requesting to have access to that ticket granting server. Okay, so I'm granting you access to that particular server. Okay, so it has those two purposes. Okay, كده? So we answered the question that we cannot send the password as plain text, and we solved that problem. And we know now why we need to send TGS. Okay, so what is the content of the ticket? Remember, the requirement of the ticket is that it's unforgeable and it has a certain lifetime. It's unforgeable and it has a certain lifetime, right? So that's why you see that in the ticket here, I'm actually storing IDC, which is the username, and ADC. ADC here represents some kind of address identifier of the workstation that the user is working from. Because I'm actually granting access not only to that user from this particular workstation. ماشي كده? And again, this whole thing is encrypted in a way that's unforgeable. Even the user cannot open what's inside. And that's why it's actually it's encrypted with a key which is only known by the ticket granting server. Okay? The ticket granting server. So that key is not known by the user. It's not a symmetric key to be used between the user and the ticket granting server. Remember, there is K, C, and TGS. This is a symmetric key that the user uses to communicate with the ticket granting server. That one is different. This one is private to the ticket granting server. And it's only known by the ticket granting server and what? And the authentication server. Every node in the system needs to authenticate itself to the authentication server. So the ultimate trust is always the authentication server. ماشي كده؟ By encrypting this ticket with the key of the ticket granting server, the user doesn't have this key, therefore the user cannot generate this ticket. Okay, طيب. So now we are granting this user from this workstation access to this particular target server, okay, and this is the lifetime and the timestamp. And the lifetime and the timestamp together will on one hand prevent the replay attack and also will allow for a certain duration of lifetime. After that, the ticket will expire and the user has to go through user authentication again. Type. Question now, because this is the authentication server, right? How does the authentication server knows the IP address? The user did not communicate that address in the request. This is the address of the workstation that the user is using, صح? Okay? But this user did not communicate that address. ايوه برافو عليك. yes وخد بالك احنا هنا application layer, right? But all these messages they have to have the IP header, the TCP header, and everything. This is application level, right? So this IP header, IP address is actually read by the authentication server from the IP header. Okay? So implicitly, actually, the user communicated the IP address of the workstation when it sent this request.
It's the IP address, not the MAC address?
The IP address. Okay? ماشي كده so far? So from now on, you will see that the format of the messages are quite similar. So here, this is the target server, and I'm sending the ticket which I got from here. Okay, so I'm using that ticket. Of course, that ticket, because I'm sending this request to the ticket granting server, the ticket granting server has that key to open the ticket and make sure that everything is fine, صح? Before giving me any access. And then I'm sending authenticator C. Now, by authenticator C, unlike the first message, because now we do have a symmetric key. Okay, so you will see that the authenticator C here is actually an encrypted message with the symmetric key that we have together. Okay, which I have also achieved in this, here, in the reply here. صح كده? So this authenticator now is encrypted with the symmetric key, and it has the authenticator content, which is again by the IDC and the ADC and the timestamp. ماشي كده؟ واضح كده؟ طيب. The only slight difference here is that because remember here we don't have a target server. We don't have a target server here. So we are sending to the service server. We are sending the ticket and the authenticator. So the authenticator here is similar, صح? But it has a DS5. Okay? So you will see in the reply we have DS5 plus 1. Why? Because we said here that if you look here, we have some acknowledgement IDC TGS and IDC TGS. Right? Here we have IDV and we have also IDV in the reply. IDV here and IDV here. صح? So IDV in the reply acts as authentication as well as mutual authentication, as well as it acts as an acknowledgement. صح? Here, but we don't have a target ID. So instead, what we do is that in the reply back, we're sending the same timestamp plus 1. So instead of sending the target server in the reply because we don't have a target server, so here we are sending the same timestamp plus 1. So the same timestamp plus 1 acts as mutual authentication. كده هنا في كلمة إيه؟ Mutual authentication here. Okay, so the service server mutually authenticates itself back to the user, and it also acts as a confirmation and acknowledgement. ماشي كده؟ So that's the idea and the detailed protocol. طبعا remember, but starting from now, we will talk about many protocols like this. So we've been talking about mechanisms, right? But now we are talking about protocols. Here you need to have the mindset that despite the fact that you know the mechanism and everything is fine, and the mechanism itself from information theoretic point of view, it looks fine and stuff like that. But sometimes the attack surface itself lies inside the protocol itself. So just by sending the messages back and forth like this, you can create an attack surface for the attacker. Although you are using encryption and everything is fine, these encryption mechanisms are proven to be good and very powerful, but because you are exchanging these messages without careful considerations, you can create some kind of attack surface that you don't know. That's why we need like security protocol designers, right? As you can see, there are lots of things here that you have to really pay attention to, okay? And you will see in later stages that you always have to pay attention to some details in the protocol design for, especially for user authentication and key distribution. مش كده؟ طيب. So this is Kerberos, and again, Kerberos is used for user authentication and key distribution using symmetric keys. طيب. How about the key distribution for public keys or asymmetric encryption? For asymmetric encryption, as we know, it's quite easier. Why? Because we have local private keys, which are not to be communicated to anyone, and then we have public keys. And as you know, public keys can be exposed, can be sent to everyone, right? But there is a glitch here. Just the fact that the public keys can be sent to everyone, does that mean that I can trust any public key to be sent to me? Of course not, because maybe I'm falling into some trap that there is an attacker sending me like some public key, right? That I can use to encrypt some messages and communicate to that node some sensitive information, and they can have access to it using the private key, and they can perform the attack this way. So just the fact that the public key needs to be sent, it doesn't mean that we need to trust all public keys that we receive from all entities. So in a way, we need to also authenticate the entity that sends the public key. So that's the main issue that we need to talk about in this particular part. Okay? So one of the major roles of public key encryption is to address the problem of key distribution. So there are two distinct aspects, the distribution of the public keys and the use of the public key encryption to distribute secret keys. More often than not, as we said before, public key cryptography is used to send the symmetric keys. So if we have public keys exchanged, we can use the public key to encrypt the symmetric keys that we send to the nodes in order to establish communication. Okay? So public keys can be used, unlike by KDC and tickets. So here we can use public keys to actually encrypt a symmetric key and send it to a user. But that also requires the fact that we have these public keys from trusted entities. Okay? So we have the concept of public key certificate. So So in order to trust any public key that I receive, I need to have this public key in a form of certificate. And this certificate needs to be signed by a trusted authority. Okay? So if you want to communicate your public key to me, then you need to communicate it to me not as a plain text like this, no. You need to communicate it to me as a certificate which is signed by a trusted entity. Okay? This is the key thing. هتقول لي how about the trusted entity? Why do I have to trust it? لا يعني at the end of the day you have to trust someone. Similar to the fact that we have trusted برضو the authentication server, and the key, at the end of the day you have to trust. So this whole thing is based on centralized trust. There is like the concept of centralized trust. Here,
managing risk.
yeah, it's managing risk بقى يعني احنا هنا we all مثلا trust Microsoft. يعني trust Microsoft, they have like a trusted authority, or we call it certificate authority servers that we all implicitly trust. Okay, same in Google, same with Google, same with Apple, things like that. Okay. So the public key certificate, it consists of a public key plus a user ID of the key owner, ماشي, with the whole block signed by a trusted third party. This is the key thing here. In order for me to trust the public key that you are sending to me, you have to have it signed by a trusted authority. We'll see about how this trusted authority is designed and how it can be used to manage these certificates. So typically this third party is, we call it certificate authority, that is trusted by the user community. So we trust entities, organizations. We don't trust users. So users, in order to communicate their public keys, they have to go through some certificate authority. A user can present his or her public key to the authority, and that's usually based on some identity management or some, you have to present yourself to this trusted authority, you give all the information and stuff like that, and then the certificate authority will say, okay, I can grant you my signature, okay, and then this signature will be used to sign the public key in a form of certificate. Then this certificate, by the way, it's like a local file. It becomes like a local file. This local file now can be, it's plain text. It's plain text, okay? Now this certificate will become like a file that you can send, either by store locally, send over the internet, whichever way you wish to communicate that file. Okay? So the user can then publish that certificate, whether store it on a server or send it over the internet. So anyone needing this user's public key can now obtain the certificate. Before you use that public key, you just have to verify that public key by verifying the certificate authority that signed this طبعا. How can we verify the certificate authority, by the way?
Verify that this certificate is.
ما هو sign ماشي. How can we as nodes يعني verify the signature of the certificate authority with its own public key, صح? Because we said that for signature, the user, or in that case the certificate authority, using the private key, صح? So we all have the public key of that certificate authority. So at any point of time, we can verify this signature that it's coming from the certificate authority by using its own public key. ماشي كده؟ طيب. So that's how it's done. So Bob sends his own ID information, identification يعني. Any kind of name, thing, any kind of identification information, ماشي? And then he sends the public key. And the public key is again text, it's plain text, okay? And I need to send the certificate authority information. I need to know who signed, because everything here is encrypted, okay? So I need to know who signed that certificate, and then this part is by hashing all of this and then encrypting that message using the private key of the certificate authority. تمام كده؟ The private key of the certificate authority. Once we do that, this becomes like a text file, gets stored, communicated over the internet in plain text. It's exposed, no problem. Once it reaches to any node that it wants to verify that this public key is actually signed by the certificate authority, what it needs to do is that it gets this certificate, part of the certificate, it hashes it, and then it uses the certificate authority's public key, okay, to encrypt it, and then it matches. If it matches, then this certificate is actually is trusted. Okay, so now we can use Bob's public key, and we can encrypt any kind of communication to Bob. The first thing we could typically encrypt to Bob is the symmetric key. So we communicate the symmetric key encrypted by Bob's public key. Once we communicate that symmetric key, now Bob and Alice would have some symmetric key that you can use for communication from now on. واضح كده؟ تمام. Okay, طيب. So using this concept, ITUT established an actually portfolio of standards, not actually just one standard. It's called X500 series. And this X500 series defines series of specifications which are used for something called Active Directory Service. Part of this is 509, which specifies the standards for how to create, store, and manage certificates. Okay. Of course, other parts of this series, they can standardize other aspects, like if you know the concept of LDAP for directory services, also, which is used for user authentication or identity management and things like that. So that is part of the X500 series, which we will talk about later. ماشي كده؟ So the directory may serve as a repository of public key certificates. So we generate these certificates using certain mechanism, and then we store it back on a directory service which can be accessed at any point of time by anyone. Because it's signed, all of them are signed with the certificate authority. It defines the alternative authentication protocols based on the use of public key certificates, and was initially issued in '88, not that we care. Currently it stays, and I think there is even version 8 and something like that, because this is released in 2012, so there should be, or there could be, some updates or some upgrades to this. So the standard does not dictate the use of a specific algorithm for signing. So it could be elliptic curve, RSA, or even Diffie-Hellman if we want, anything. Okay, so it does not dictate a certain public key cryptography technique, but it recommends the use of RSA. It only recommends. Okay, but if somebody chooses to use elliptic curve, they can do that. And they still comply with the standard. There is no problem. So this is the format of the certificate. So of course you have to specify the version, because based on the version, as you can see, some fields here are not actually valid in later versions. Okay, so the format is slightly different. So in version 1, we didn't have to have the issuer unique identifier and subject unique identifier. We'll talk about why these are used. Okay, in version 2, we didn't have to have the concept of extensions. So we'll talk about the concept of extensions. ماشي كده؟ طيب. So any certificate would have the certificate serial number. It's like an identification to the certificate itself, to the entire certificate. Okay, and this part is redundant. You don't have to worry about this part. This part is included in the standard, but it's not actually used, because all of these components, you will see that they are stored here. Again, so this part is actually, to me, it looks redundant. So the issuer name is the name of the entity that issued that certificate, or the certificate authority name يعني, or name يعني. It's like the name ماشي. And this is the user name. The user name ماشي. Bob. Okay. So here is like names, normal names. Okay. So here بقى the period of validity. So not before and not after. So any certificate, by the way, it needs to have some lifetime as well. Okay. So before that duration, the certificate is not to be used. After that duration, the certificate is not to be used. Remember, because these are going to be eventually stored on the directory server, right, as plain files. So anyone can pick it up and can verify Bob's public key, even though this certificate has been updated or has been revoked. We'll talk about revocation of these certificates. Okay, so the certificates that are stored as files might actually be expired, might be old versions, and they need to be updated. So if I fetch any certificate from the directory server, and then I verify that the current time is either after this time or before this time, then I do not, or I should not use that particular certificate file. So this is the period of validity. ماشي كده؟ So that's the most important part. So this part is the most important part, right? So this is the minimum. This is included in version 1. This is Bob's public key. And here, the public key, this is the key. This is the actual public key in plain text. ماشي? And this is the algorithm that has been used for that public key. Could be RSA, could be Diffie-Hellman, anything. Could be elliptic curve, could be anything, right? And these are parameters. These parameters are required to be used by the algorithm. Like, for example, remember we said that مثلا for Diffie-Hellman, we need to communicate the alpha and q. Remember, an alpha needs to be a primitive root of q, and we need to communicate. Of course, for RSA, we cannot communicate the p and q, right? We cannot communicate that. So ما تحط يعني never put p and q here, or everything is done. خلاص كده خلاص, you are done. Okay. So we don't have to factorize, we don't have to do anything. But for some other algorithms, elliptic curve, we can communicate certain parameters that it needs to be used with the algorithm. Or in Diffie-Hellman, we can communicate alpha and q. There's no problem. Okay, and this is the actual key. طيب, for the issuer unique identifier and the subject unique identifier, these are part of version 3. Or version 2, sorry. These are part of version 2. Why? Because in a later stage, it has become really things have become more complicated. And it came to the fact that the certificate authority may in fact have multiple public keys, similar to the subject or Bob. Bob may in fact have more than one public key. Maybe one public key is used for مثلا any services related to banking. The certificate authority has certain public key which is used in a specific domain, things like that. Okay? So here, in order for any node to verify the signature of the certificate authority, okay, it needs to know which public key that the certificate authority used to sign that certificate. Okay? Because it may have multiple keys. So that's why we need it here in version 2 to include the issuer unique identifier and the subject unique identifier. طيب. That's up to version 2. Version 3 بقى came with the concept of extensions. So we know the period of validity for the certificate. There's no problem. But extensions here define some limitations on the certificate. Limitations on or some constraints. يعني for example, مثلا, this certificate is used for banking only, or these certificates are used in certain مثلا domain or in certain criteria. Okay, so other than the period of validity, خلاص validity we agree, this is basic. But extensions add more restrictions on the certificate. It's used in certain scenarios and not to be used in other scenarios. ماشي? So these are the extensions, and we'll mention some examples about that.
For example, practical, like the certificates you have to, for a web server, for example, you have to include the domain name of the web server in the certificate issue.
But this could be the subject unique identifier. This could be like this. It could be the subject unique identifier. But extensions, for example, يعني this certificate is good, but it cannot be used for banking services, for example. I can use it for general, مثلا email service, things like that. But I cannot use it for banking services. Okay? So for banking service, I need to have another certificate. ماشي كده؟ And that's the signature بقى. This is the signature. So unlike here the algorithm is RSA or elliptic curve or Diffie-Hellman, things like that. Here بقى the signature is actually the SHA1, SHA2, because this is the hashing algorithm. So this actually refers to the hashing algorithm. And similarly, I need to have the parameters and then the signature of the certificate. So this is the hashing part of the certificate authority. Okay?
I have a question.
تفضل.
Regarding to the extensions, it's same as like Microsoft Office that has a different version for community and different version for the business, like this.
Yeah, could be,
So
yes,
it
could
has
be.
one certificate and different extensions.
Yes. Okay, but يعني
File extension, like file extension, like
لا.
Office, for example.
لا.
extension to DOC or ES.
لا هو extensions يعني defines any kind of restrictions on this certificate. It can be used مثلا for professional version of Windows, or it can be used for مثلا Google service, but it cannot be used for banking services, or any kind of restrictions.
But not for a specific program, like.
It could be for a specific program. It could be. يعني it can be formatted in a very generic way, such that this certificate is only valid to be used for a particular program. Okay, and not to be used for any other program. So I can put whatever restrictions and constraints I need to have. Okay. So we have two things. We have the period of validity and the extensions, which might add some restrictions other than the timely restrictions, the time-based restrictions. Okay. So that could be domain thing, program-specific thing, anything. ماشي؟ طيب, so user certificates generated by the certificate authority have these characteristics. One, the certificate authority's public key can verify the user public key that was certified. And in order for me to verify that, I can easily use the public key of that certificate authority. No party can modify the certificate other than the certificate authority, because again, it's hashed with the encrypted, or it's hashed and encrypted with the private key of that certificate authority. So if you have updated that certificate in any way, the signature of the certificate authority becomes invalid, and you can easily verify that this message or this certificate is invalid. ماشي? Certificates are unforgeable, of course, similar to the ticket. Unforgeable. So I can store it on the directory service and so on and so forth, but I cannot modify it in any way. If I put like 1 byte different, خلاص, becomes invalid. All user certificates can be placed in the directory for access by all users. خلاص. Certificates become plain text files. They can be stored on the directory, and everybody can use any of these certificates to verify the certificate authority. If I can verify the certificate authority, then I trust the public key inside it. ماشي كده؟ In addition, a user can transmit his or her certificate directly to others. So I can store it on I can store this certificate on a centralized server, or, I can get my certificate, which has my own public key, and then I can get this certificate and communicate it to others. And all other nodes can now verify that this public key is trusted because it's stamped and signed by the certificate authority. المشكلة بقى في إيه؟ If there is a large community of users, it may not be practical for all users to subscribe to the same certificate authority. This is the problem. You can never imagine the fact that there's one certificate authority for the entire internet. But we have nodes communicate over the internet. So how can these nodes trust the public keys of each other while they have different certificate authorities?
There is standard. There should be a standard.
ما هو this is part of this standard بقى. ما احنا بس عايزين نشوف ازاي بقى. So we need to know how we can verify, or how can we trust a public key of someone that's not connected, or I don't have direct trust with through my certificate authority. ماشي? So because it is the certificate authority that signs the certificate, each user must have a copy of the certificate. طبعا this is عادي. With many users, it may be more practical for there to be a number of certificate authorities. This is not the problem. If we have number of certificate authorities, how can we manage this trust? So that's what we need to discuss. So consider a scenario, very simple scenario. And this is a very simple scenario. Later on, we will complicate that. Type, a user A obtained A's certificate from certificate authority X1. So we have simply, so here we have A, and A has a certificate authority called X1. And now A has its certificate, signed by X1. Type. Another user, B has its own certificate signed by X2. So now, in order for A to communicate with B, A needs to have some trust with B's certificate authority. So we need to have this back. If and only if we have some trust relationship between X1 and X2, then in that case, now A can use the certificate which is now signed by X1 to verify or to have some trust relationship with X2. And then from X2, it now can have some trust relationship with B. ماشي? So we can have this, we call this chained certificate. So this is called a chained certificate. ماشي? So, in other words, we have a trust relationship between A and X1 through a certificate which is signed by X1. So we can use that trust relationship to verify ماشي, the trust relationship with X2. And then from X2 we reach to B. So this means that we need to have a certificate that binds the relationship between X1 and X2. We call this cross certificate. ماشي? So this chain certificate has X1 to X2 using this cross certificate, and then from X2 we can now verify the public key for B. ماشي كده؟ So we can trust B through X2 through X1. That's what it means. ماشي كده؟
That means X1 and X2, they exchange their public keys.
Yes. So X2 needs to exchange that public key with X1. So these certificate authorities, in other words, يعني, these certificate authorities, they need to exchange their public key together.
They need to trust each other.
They need to establish some trust between each other. ماشي كده؟ And this trust sometimes may be based on a third party.
Yeah, there has to be some certification.
ما هو the question is, so why stop at X1 and X2? So there could be, okay, and this could have like some relationship between those two, okay, through which they can. So I can actually go this way, okay. ماشي كده? So that's the complicated scenario that we have here.
And actually, who is that?
Eh?
The main authority.
Yeah, we call يعني all of these they trust V now. So we call V has multiple branches, right? So we call V now root certificate authority. ماشي كده؟ root certificate authority. يعني مثلا, in other words, Microsoft does not directly trust Google مثلا. ماشي? But it trusts مثلا I don't know, the Ministry of IT in the US مثلا. Okay? They both trust the Ministry of IT. ماشي? So Microsoft can establish some trust relationship with the ministry, and Google can establish some trust relationship with the same ministry, through which they can trust each other. So they trust each other indirectly. Okay? So each line in this tree, okay, signifies a trust relationship. A trust relationship. It's modeled, remember, it's modeled here as a tree. And in fact, in the book, there is a missing line here, because as you can see here, if you see X and Z, so X has direct relationship with Z, which is represented by this certificate here. So in the book, this line is removed, and this is only to give you an indication that it's actually a tree of trust. But in general, it could be a graph. In general, it could be a graph. And in the same level, this we call it again cross certificate. Okay? So if you go this way, we call it reverse certificate. If you go this way, we call it forward certificate. And these are the definitions here. So this is this definition here. So we have forward certificates. So if you have, like for example here, VW, this certificate establishes the trust between V and W. So we call this a forward certificate. بينما WV here is a reverse certificate. And XZ, because they are on the same level, we call it cross certificate. ماشي? And remember, just the fact that it's modeled as a tree or as a graph, it doesn't mean that these trust relationships are stored on the directory server as a graph like this. At the end, all these are certificate files which are stored on the directory server. And they can be cached at any node based on which node you want to communicate with at any point of time. So we'll see about how this is done. So we know now the definitions in this trust relationship. We know the cross certificate, we know the reverse certificate, the forward certificates. So now, if, مثلا, for example, C wants to establish some trust with B, okay? So what we need to do is that if C establishes some trust or has some trust already with V, then we'll start from V. Okay? If it has some established trust with W, then we'll start from W. If it does not have any trust relationship, at least it has trust with X. It has to have trust with X. ماشي? So we can start with X. And from X, we can, for example, we have two ways. We can use XZ. We can use the cross certificate to go to Z. And from Z, we go to E. This is the shortcut. Or we can use X to go to W using the reverse certificate. Okay? And from W we go to V, we use the reverse certificate. And then from V we go now to Y using the forward certificate. And so on all the way لغاية B. And this is called the chained certificate. Okay? But again, يعني someone might ask, do I have to do this every time I need to communicate to B? The answer is no. Because remember, these trust relationships are cached in every node. Okay? So a node may have in the cache some trust already with Z directly or with Y. Okay? Depending on the context of the communication. ماشي? So it starts from where it trusts and then it goes down to B. واضح كده؟ So from C to A, it's direct relationship. So we have X, so we can go to A directly. So there's no problem. ماشي؟ واضح كده الكونسبت؟ All of these certificates are stored on the directory server. Or they can be cached in different nodes. Any questions? Any questions? Anything vague? Anything weird? Okay, so let's have a break. طيب. So to continue that subject, we need to talk about two things. We talked about the concept of extensions, and we'll highlight it again here. But there is a concept of revocation. So just the fact that we have certificate and it's valid from a timely manner, it doesn't mean that this certificate is always valid. We can decide to revoke a certificate, although
It's not expired.
it's not expired. Why? Like a very simple example. Somebody مثلا decided to resign from QU. They have a public key through their work at QU, right? And now they have resigned from QU. So this certificate now, it has to be revoked. صح? Because they moved to somewhere else. They can go to somewhere else and abuse this certificate somehow, right? So once you become not affiliated to a particular entity or organization, your certificate, it has to be revoked. Another extreme example is that if a certificate authority decides or a certificate authority is compromised. ماشي? A user or a certificate authority become compromised. So all the certificates that are signed by this certificate authority are now compromised and they have to be revoked. Okay? So in order to manage that, we have a certificate revocation list, which has to be regularly communicated to all parties, all the nodes. Okay? So separate بقى from the certificate files, we have certificate revocation list, which needs to be also communicated regularly. We need to regularly send these revocation lists. ماشي? So typically a new certificate is issued just before the expiration date of the old one. So يعني we have the not before and not after, right? So these are the period of validity. So before a certificate expires, another certificate might get created. Okay? So now we have two copies of that certificate, and there is an overlap in terms of validity period. So that should not be the case. So in order for us to manage this, we have to revoke the old one. So that's one scenario, okay, based on which we need to revoke an existing certificate. Okay. Another scenario, as I said, is that someone مثلا moved from one organization to another, or someone is compromised somehow. We know that there is a person or a certificate authority that has been compromised. ماشي؟ اللي هو this example. So the user's private key is assumed to be compromised, or a certificate authority is compromised, or the user is no longer certified by this certificate authority. The reason for this includes the subject name has changed, or the certificate is superseded, or the certificate was not issued in conformance with the... Sometimes people use a self-signed certificate. Have you heard about this?
Yes.
Self-signed certificate. Yani someone sends his public key signed by his own self. What is the point of this? Okay? So in that case, you might automatically revoke that particular types of certificates. ماشي؟ طيب. So for all these scenarios, for all these reasons, we have to have some certificate revocation list. So each certificate authority maintains a list of revoked or not revoked, يعني, which means not expired, huh? Because if it's expired, it's automatically not valid, right? So, but here, revoked and not expired. ماشي? And it's issued by that certificate authority, and it's now communicated to other certificate authority, and it gets communicated to all the parties. So this certificate revocation list posted to the directory is signed by the issuer. Again, similar to the certificate file itself, it also has to be signed by a particular trusted authority. ماشي? So this revocation list includes the issuer name, the last creation date, which is the last date that this list was created, and the next list creation date. Why do we need to include the current creation date and the next one? Because as we said, this certificate revocation list needs to be generated regularly. It could be like every week, could be every month. Okay, so if someone decides to fetch the current certificate revocation list, okay, and then finds that, okay, so the last creation date seems to be in the past, so that's fine, but the next creation date is also in the past. What does that tell you? This tells you that what you are actually fetching from the server is an old list and it was updated. Okay? So this certificate revocation list itself is invalid. So you need to go and fetch the updated one. So these two dates are similar to the period of validity for the certificate itself. So the next creation date tells you that the upcoming date is after 1 week or after 1 month. Okay? So if that month elapsed and you are trying to fetch that list, okay, then that will allow you to recognize that this list is in fact old and you need to go and fetch the new one. ماشي؟
Prof, can I ask one question?
اتفضل.
يعني someone contacts the CA to verify some public key of another user, and the CA then will check.
No, this is sent periodically كده. Yeah, this is sent periodically. No, we don't really have to ask for it. This is sent periodically.
In some cases, like in web server, certificate is valid
Right.
for 1 year. So once I do it.
But this is for expiration, not for revocation.
So once, like one of my certificates is expiring next month. So when it reaches the day before that expiry, I have to create a new one.
Right.
And then revoke the old one.
Revoke the old one, yes.
And then reconfigure the new one, then the April one.
Right.
Otherwise, if it is expired.
So the key here is that you need to revoke the old one. So by revoking the old one, which means that you need to send the revoked one in a list. And this list is not, you can request it, but usually it's sent periodically and regularly to all parties. Okay? And again, all these certificates, they get cached in local nodes. They get cached. Again, they are files. يعني text files. They can be cached or stored on files, on the file system, or it can be cached in the memory. Okay, so at any point of time, after you validate a certificate and everything, if it's included in the revocation list, then that's another reason that you can just ignore that certificate. ماشي كده؟ Then the list of entities, and we can revoke the certificate by what? By the serial number. مش احنا we included the serial number in the certificate. خلاص, we include this serial number and the revocation date. That's it. And it's actually it's like this. So this is the issuer date and the update date and next update date, as we said, and the serial number and revocation date. That's it. So starting from that date, the certificate is not valid. Okay? This could be immediately, it could be after 1 day, it could be after 1 week, whatever. And this, by the way, this revoked certificate is actually repeated. So you can send a list. So in one update, you send actually a list, not just one. You send a list of them. And this is again signed by the certificate authority that sends this revocation list. So that's the concept of revocation. Now, the concept of extensions, as we said, we actually talked about the concept of extension. There is the period of validity which makes the certificate expired after some time, but there is also the concept of extensions. Extensions here convey additional information about the subject and the issuer keys, plus indicators for some certificate policy. Policy here refers to the fact that there is a certain policy through which this certificate can be used. Okay, so the policy here restricts the particular usage of the certificate. ماشي? So a certificate policy is named set of rules that indicate the applicability, okay, of a certificate to a particular community. So I can restrict it to be used within a specific distributed system, or a specific program, as you said, or a specific service, banking, for example, or anything other than banking, things like that. ماشي كده؟
Is it possible to fake these certificates like in crack programs? They use also certificate.
In what?
Crack programs.
grad programs.
Cracked.
Cracked programs. Yeah, ما هو in cracked programs and these things, they usually use what we call self-signed certificate. Self-signed certificate, it's signed by the person who is trying to communicate the public key. So what is the point of this? But there are some programs that يعني انت الغرض ان انت you want to create a certificate that looks, from a formatting point of view, it looks right. So the easiest thing is just to self-sign it. So you can self-sign it, okay? So and then you send it to people. In some cases, these certificates can be accepted.
It depends on the.
It depends on the programs. It depends on the client. But
Can accept, can trust this.
especially some people, they use self-signed certificate for testing. إنما for if I want to deploy a specific service on the internet, لا خلاص بقى I have to establish some trust relationship with a certificate authority. And sometimes this is a process. يعني you have to identify yourself to the certificate authority and so on. And it's we'll talk about identity management.
How they generate these keys? Because they.
Keys what? Which keys?
For also for crack programs, you can assign a specific key and it's one. Like I found this especially in MATLAB and this.
key generators اللي هي بتاعت الحاجات الكراك دي.
No, this is something. This is something else. Yeah, this is something else. يعني. This is something else. Yeah, لا here there are multiple ways to crack these programs. Multiple ways. It could be it could be like some attack programs, some key generators, some brute force techniques, anything like that. ماشي? There are multiple ways. It's not like one size fits all.
And all are illegal.
Oral illegal بالضبط يعني. We shouldn't talk about that. Oral are illegal يعني. ماشي? طيب, so for example, a policy might be applicable to authentication of electronic data exchange, so a particular service transaction for the trading of goods within a given price range. So all types of restrictions can be defined as part of this extension. طيب, So, so this is the part of key distribution using public cryptography. So we talked about key distribution as part of Kerberos for symmetric cryptography, and we talked about the same key distribution using public cryptography. Now, there is the last part of this chapter talks about identity management. Identity management here talks about the centralized automated approach to provide enterprise-wide access to resources. So this is about the part where we need to give some, not only by authentication, but authorization, which is the one that you mentioned in the beginning. So based on your identity, okay, we need to give you certain role, okay? And not only that, but this role can be exchanged with external systems, okay? So your identity can be shared with external services. We call that type of sharing, we call it federation. We'll talk about this, okay? اللي هو اسمه identity federation. Okay? So for example, a very basic example. Here at QU, مثلا, we have certain identity, and all our identities are stored on the system. Based on this identity, we all get different roles. صح? I get a role as a faculty member, you get a role as a graduate student, and somebody gets a role as a finance مثلا officer, somebody gets a role as administrator in IT, and so on and so forth. Given this role, we get some privileges, صح? To have a specific access to different parts of this system, whether it's a service or a particular node on the network, or a network مثلا part, or a specific router, specific switch, anything like this, a specific network resource, okay? طيب, after we have identified ourselves to the system and we got a role, okay, our organization, in fact, has some relationship with some external vendors. Like, for example, we have access to OneDrive, okay? Through our access in the network, we have some access to OneDrive. So now our identity is shared, and we call it federated, okay, to be shared with Microsoft. And through that identity federation, we get access to OneDrive as a user. So I have a role in Qatar University as a faculty member. When I have access to Microsoft OneDrive, I get a role of a user through my identity at Qatar University. Okay, same thing, مثلا, Authenticate. We have access to Authenticate, or Turnitin, or something like that, right? Any other external source. So this is in a nutshell how we manage this identity. So identity management here the focus here is defining an identity for each user, whether this user is a human user or a specific drive or a device, or a specific مثلا router, or a specific server, or a process, a program, like Blackboard, things like that. ماشي? Associating attributes with the identity. Associating attributes يعني if I'm a human being مثلا, if I'm a user مثلا, I have certain attributes, like مثلا what could be my credit card. As a faculty member مثلا, I need to have some attributes which is stored in the university, like مثلا my PhD مثلا stamped certificate مثلا, okay, which is stamped by another, and so on. I need to have certain attributes, okay? So طبعا, of course, my name and address and all of this, these are my identity information. But I can have some attributes. Attributes could be my credit card, could be stored somewhere مثلا, okay? Anything additional to my identification. Okay? طيب. So I have some identity information and I have some type. There is a central concept is used for single sign-on. So based on my identity, I get some credentials, and these credentials could be in a form of single sign-on, which means that now I have one credential, which is my user ID and password, which allows me to access all services in this organization. Not only in this organization, all مثلا services in OneDrive and MATLAB, cloud, anything, okay, through the same credential, which is maintained by my organization. Okay, so this is what we call self sign-on. This self sign-on, if you know, this is actually a, so you authenticate yourself to مثلا اللي هو central law LDAP. So LDAP is one example that authenticates users using one credentials, and it gives you access to all services. طيب, given this, we have some definitions. So we know the concept of authentication. So authentication, we use the self sign-on to do the user authentication. Here we refer to user authentication through single sign-on. It could be reduced sign-on. We'll talk about the difference between the two. Based on our authentication, we have some authorization. So authorization here is to grant a certain role based on your identity. Okay? So if I authenticate myself to Blackboard, for example, Blackboard will give me the role of faculty member. Based on that, I have a certain access to Blackboard, which is different from yours. So this is a authorization. ماشي? I get specific access based on my identity. Accounting here refers to logging access and authorization. Why? Because the more you use the service, you may actually go outside of your limitations in terms of accessing. Like, for example, you use the email, and then you exceeded the quota of your emails. ماشي? I have, for example, 10 gigs of email on the server, and at some point I exceeded that boundary. Okay, so I have to use some accounting in order to monitor the usage of the user and stop it or revoke it or suspend it at certain point of time. Accounting or boundaries, specifying these boundaries is based on provisioning. Okay, provisioning here, of course, the people at ITS, they have to do this process of provisioning. Provisioning is like you are provisioning resources to users. So for example, they know that they have a specific مثلا total amount of مثلا file system size and so on. So based on that, so we can roughly give the faculty members مثلا 10 gigs of email. But for students, we have to give مثلا 5 gigs of email. Okay? So if they increase or they upgrade, okay, so now we can give 20 gigs for faculty members, 10 gigs for users, and we can have مثلا up to 5 devices on the مثلا on the Wi-Fi. مثلا for faculty members, we can allow 10 devices. So this is called a provisioning. ماشي? So provisioning here is like dividing the network resources, okay, on the different roles, depending on the roles, and of course the role is based on your identity. واضح كده؟ طيب, workflow automation specify a sequence of events based on your role, which is again يعني similar to the example that I just talked about. So if I log on to Blackboard, I get a totally different workflow, different from yours. I get different screens. In many instances, actually, the students, they tell me, okay, we cannot see, for example, the assignment. How come? I actually posted the assignment. So when I log on, I see the screen and the assignment looks visible to me, but the students cannot see it. Why? Because they see a totally different workflow. Okay? In order to make it visible for students, I have to specify certain things in order to populate the assignment in their workflow, based on their role, and so on. So the workflow automation here talks about a specific sequence of events based on the role. ماشي كده؟ طيب, delegate administration. Of course, you cannot imagine that a system, especially sophisticated and big systems like مثلا QU, they have one single administrator for all services. Of course, no. So we have an administrator مثلا for email, we have an administrator for Blackboard, we have an administrator for this and that, and maybe حتى within Blackboard there are multiple administrators for different parts and so on. So this is called a delegated administrator. Password synchronization is a very interesting concept. We talked about single sign-on, right? So password synchronization here talks about the fact that after some time we get asked sometimes to change our password, right? So when we change our password and we have the concept of single sign-on, the password will in fact get synchronized between all the services. صح كده? So if we use single sign-on, our new password should become immediately valid for all services. I should not have one service as an exception if we use single sign-on. Okay. Type. What's good and what's bad about this? What's good about this is that it's convenient. So once you change your password, and you should, after some time, you should change your password, right? You should change your password regularly. And it's convenient. Once you change your password, it becomes valid for all services you are accessing. So that's good. صح? It's convenient. It's not good from the security perspective. Why?
Because you said that.
Because not like this. No. If one password is compromised, this means that the attacker would have access to all services. صح? So self sign-on or single sign-on is convenient for the user, but it's not good from a security perspective. Okay? And it's always like this, by the way. Always security principles are against the convenience of people. Oh, this is like a general rule. It's like a theorem. Always security is against the convenience of people. ماشي؟ طيب. That's why we have the concept of reduced sign-on. This means that by changing your password, the old password might still be held valid for certain types of services. Okay? And you have to maintain your old password in addition to the new password. Okay? And this in fact happens, I think it happens by coincidence. حتى the people with ITS, they don't really mean it. بس يعني مثلا sometimes I change my password and there are some external services that we use, okay, and I find that these external services, the password is not synchronized. Yeah, for example, مثلا I change my password to a new password, okay, and then I try to log on to Authenticate or to another service that we use, which is not valid for you. It's called Digital Measure. We use it for evaluation. It's a lot of pressure. So we use it for internal things. It's called Digital Measure. Okay. So if you try to use Digital Measure with the new password, it doesn't work, and you find that it uses the old password. Okay. So this is called a reduced sign-on. So the synchronization does not happen across all services. Okay. So I'm talking about examples for external services, but sometimes reduced sign-on is even used internally. So when you change your password, some internal services might still use the old one. And that's actually better from a security perspective, because it creates some kind of isolation. So even if somebody compromises your password, they will not have access to certain parts or certain services, especially critical ones. ماشي? So reduced sign-on talks about the fact that you will have different credentials for different parts of the system. طيب, self-service password reset. طبعا, this is easy. Sometimes we put a policy that every 3 months, 4 months, we have to reset our password, so that's easy. And now there's a concept of federation. This concept of federation is how to share your identity across different entities or different organizations. Okay, so this identity federation is somewhat complicated. Why? Because sometimes I need to share your identity but not your role. And sometimes there is a mapping from your role in the host organization and the service organization. There is a mapping. So if I'm a faculty member, I need to be mapped to a user. If I'm a student, I need to be mapped to, I don't know, to someone else in the external service. If I'm مثلا يعني for example مثلا people in finance مثلا they take a role as finance officer ماشي, but they have access to external vendors where they actually procure some مثلا equipment ولا something like that. Okay, so if I do some identity federation to that external supplier, this finance officer all of a sudden becomes like a purchaser on this other system, and they have certain limit of money مثلا to buy equipment or whatever. Okay, so identity federation, I need to share your identity information, and I can share the same role or map the role to another role on the external system. Okay, so identity federation is somewhat complicated.
It's in some way like it's same as single sign-on, like federation.
لا single sign-on talks about single sign-on يعني it talks about synchronizing the password, synchronizing the credentials, but for the same user and same authorization, same role, same everything. Okay, but identity federation here, we can share, for example, your identification as an ID, but we don't have to share your name. We can share part of your identity, but not to expose your identity. We can share certain attributes, or we can, in fact, avoid sharing some attributes. We can share the role or map the role. ماشي? Different combinations.
Can I give example from
اتفضل.
work also in I work in Hamad. So there is one Windows login, and they decided to install SSO software. So after this one was installed, we have as users access to a platform called Cerner.
Yes.
And we have Oracle also on different platform. Cerner is for patient data, and Oracle is for employees' data and salary, vacations, and things like this.
Yes.
So we have different platforms to sign in. Everyone has username and password. Once we activated this SSO one time, only signing the Windows password one time in the session
Gives you access
gives
to
you access to
Oracle and
different
Cerner and everything.
passwords, different username and password for all applications in the PC are open without me logging in again. So this one is
This is a single sign-on. This is the single sign-on. ماشي. For identity federation بقى it's slightly different بقى. For identity federation, if you are trying to, again, Hamad مثلا is trying to access some suppliers to procure some medical equipment. Okay? So who has the authority to do that? Maybe certain role inside Hamad. Their role will be mapped to a purchaser from this supplier, not you. You, مثلا, as an IT employee, you don't have the role to be mapped to a purchaser on this supplier. Okay? But if you don't have to have access to this external supplier at all, then your identity is not going to be federated or shared with this supplier in any way. But in some cases, there should be some level of sharing. Okay? In which case, your role might be mapped. So that's the federation, which is slightly different from the single sign-on. So this is the last slide we'll talk about today. So the principle here talks about the user. So this user will have two things. We'll have some identity information. This identity information is maintained by identity provider. ماشي? So like QU مثلا, I need to have مثلا my name, my all my identity information, okay, needs to be managed by QU as identity provider. And I need to have some attributes. Like بقى مثلا ايه, I don't know, my user, my مثلا position, my credit card information, anything like that. ماشي? QID مثلا, things like this. Okay? This is managed and maintained in the attribute service. And sometimes the administrator has access. Why? Because the administrator can give you attribute. One of the attributes is the role. Yes. So the role is one of the attributes which can be updated by the administrator. So based on your attributes and based on your identity, okay, the administrator can give you a role to be able to access different parts of the system. ماشي? And based on the attributes and based on the identity, you can then have access to different parts of the system based on your identity and based on your role. So the data consumer here refers to the resources or to different parts of the network or servers or something like this that you can have access to based on your identity. ماشي كده؟ We'll talk about يعني identity I think لا في details أكتر.